Morning all. So in the previous class, we have discussed about blast furnace output, that is hot metal, as well as the slag, and also we have discussed about the applications of slag. Today we will discuss about the another outcome, the blast furnace, that is BF gas. So the hot metal as well as the slag basically comes out from the bottom of the blast furnace, whereas the BF gas, the off gases basically comes out from the top of the blast furnace. And the blast furnace basically generates around 1500 to 1700 normal metric cube of gas per ton of hot metal, which is one of the important byproduct of the blast furnace. And this will account about one third of the total energy input into any blast furnace. So, and also this BF gas is having a very high calorific value. So we can reuse it by giving sufficient treatment before we subject for the utilization. This BF of gas basically consisting of certain amount of dust will be there. And the generation of the rate at which it generates is around 40 to 50 kg per ton of hot metal. So before we use this off gases at the different parts of the integrated steel plant, it is very much necessary to do the cleaning of this gas, because the dust, whatever it is associated with it, that will accumulate at the different parts wherever we are using, and there is a possibility of wear out of some of the parts that takes place because of its raw utilization. So to avoid this thing, this BF gas is subjected for cleaning system so that the dust particles will be free from the gas, and then that gas can be utilized for further applications. So basically, this BF gas is consisting of carbon monoxide around 20 to 24%, and it also consists of carbon dioxide around 18 to 23%, and nitrogen around 50 to 57% it is having, and rest all in a minor quantity, sulfur, sulfur, nitrogen. Basically, this BF gas is used in cooking of the stoves, blast furnace stoves, and also it is used in other parts of the integrated steel plant, like used in sinter plant as a fuel. It is also used in coke oven plant as a fuel, so like that. But wherever it is used, but before its utilization, um, it used to be clean. The BF gas should be clean. The dust particles, whatever are associated with the BF gas, that should be clean. And for that, we use certain cleaning devices. They are called as blast furnace gas cleaning units. So here in this particular picture, you can see that there are three-stage cleaning process which we can witness here in this particular picture. One is the dust catcher, and then you have a scrubber, and then the third thing is electrostatic precipitator. So the dust, whatever is associated with this off gases, that will be segregated in three-stage process. Coarser, coarser particles, then you have semi-fine and fine particles, like that. So these dust particles, whatever are associated with the off gases, its size will be ranging from 6 mm to certain microns. So as I said, that these dust particles are uh, ranging from coarser to fine particles. So uh, this segregation will be done in these three gas cleaning units. The coarser particles will be removed at the scatter stage, and then semi-fine will be removed. Semi-fine particles will be removed at the scrubber stage, and very fine particles will be removed in the electrostatic precipitator. So the first stage of gas cleaning process is the dust captures. So the off gases which comes out from the top of the blast furnace to the uptakes, these are called uptakes. These two are called as this one, and these two are called as uptakes. And these uptakes are connected to the downcomer. That is a pipe which is connected from the top of the blast furnace to the one of the gas cooling system. So these uptakes are connected to the downcomer, and from the downcomer is connected to the dust catcher. So the off gases which comes out from the blast furnace will enter into the dust catcher. Dust catcher. So the dust catcher is the first gas cleaning system, and the coarser particles are basically separated from the body of gas in this dust catcher, and this separation will be done basically in the dry condition, and whereas the semi-fine particles and the fine particles are basically separated in scrubbers as well as electrostatic precipitators. And the semi-fine and fine cleaning is carried out either in the wet form or in the dry condition. Preferably, it will be in the wet condition because the efficiency of removing these particles from the dust will be better in the wet method. And the uh, fines, whatever are segregated from the off gas by this wet method, certainly it will be collected in the form of a sludge, and this sludge will consisting of Fe around 30 to 32%, silica will be around 6 to 7 approximately, and alumina will be approximately 2 to 3%, along with a certain amount of lime around 2.5 to 3%, and traces of sulfur and sometimes zinc may be present. So, and this sludge, whatever it is collected from these gas cleaning units, that is from the scrubbers and electrostatic precipitators, that consisting of certain amount of Fe content is there. So we can use that as a secondary source of iron bearing material in the agglomeration process, either in the sintering or in the pelletization. So we will move on to the first gas cleaning unit, that is the dust catcher. So in the dust catcher, if you see the structure of the dust catcher, if you see, it is basically a refractory lined vessel. Okay, and this hash part, whatever it is visible, it is a refractory lining made of fire bricks, and you can see the this bottommost part of the downcomer is connected to the topmost part of the scrubber. Okay. So here it is actually this is the end part of the downcomer and the starting part of the dust catcher. Okay, and this dust catcher basically operates on the principle that the dust, whatever it is contained with this off gas, um, by virtue of its velocity. So, if you want to segregate the dust from these off gases, we need to make the velocity of this off gases, velocity of the off gas, we make it to zero. If we can make it to zero, then the dust will be segregated from the off gas. And to make this velocity zero, what we are doing, is that the dust catcher is designed in such a way that passage of these off gases from the dust catcher to the out of this dust catcher in such a way that the path is designed such that it will come down and then it has to take up. When this reverse during its reverse direction, velocity of these gases will, because the outlet is here. So whatever the gases which enter into the dust catcher, it has to go out in this particular direction only. So during its reverse direction, in upward direction, reverse upward direction, the velocity of the gas will be zero, and because of it, the dust particles will get segregated out from the off gas, and that segregated dust, whatever it is there, that will be accumulated bottommost part of the your dust catcher. Okay, and the off gas will the clean off gas will move out of this dust catcher from this outlet to the next gas cleaning system, that is the scrubber. So uh, the coarse dust, whatever it is collected at a bottom cone of the this is the bottom cone of the dust catcher. So that will be basically removed periodically, and this efficiency of this dust catcher is usually around 60 to 75%. For an inlet dust loading of 20 to 25 grams per normal meter cube. And dust catcher can reduce the dust content to 4 to 6 grams per normal meter cube. And after dust catcher, the gas is sent to the next gas cleaning unit, that is the scrubber. So scrubber basically, it is a, you can see the, again, there is a connectivity between the scrubber and the dust catcher. The outlet, you can see the design of the outlet of the dust catcher is basically connected to the inlet, because you see here the outlet is at this position and the inlet is this is the inlet. So this pipe will be connected to this one here, so that from the off gases will travel um, from the dust catcher and it enters into the scrubbers. So this scrubber is basically a tall cylinder with a conical top and bottom, and the gas enters in this scrubber from the bottom at an angle of nearly 50 degrees and leaves through a centrally located outlet at the top. This is the outlet and this is the inlet. And the water is fed from the top. You can see here there is a sprinkling jet system is there, where the water sprinkling will be taking place here. So because of this kind of arrangement, the uh, the, the dust, whatever it is accumulated at the bottom, will be in the form of a slurry, because it is a wet method. And this and here inside this scrubbers, we have several wooden packing system is there. Several layers of wooden packing system is there with certain amount of perforated holes are there fitted to this. And this wooden packing with holes are fitted to break up this gas flow into small jets, thereby to bring an intimate contact of gas and water. So the dust contained in the gas stick to this wooden packing and is washed down with water from the top. So the scrubbers not only clean the gas, but it cools it because it is a wet method. So the temperature of the gas also will be cooled down. So from the bottom, it is going, and through this perforated wooden frames, the gas will be passing out, and because you are sprinkling from the water from the top, uh, so the dust particles will stick to this wooden frames, and it will be separated and collected at the bottom, and the gas will be traveling from the top of the scrubbers. And as it is a wet method, certainly the temperature of the gas also will be reduced to around 30 to 35 degrees centigrade. In the slurry, whatever it is collected at bottom, that will be removed continuously. So by this way, by this method of gas cleaning system through the gas cleaning through the scrubbers, around 80 to 90% of the dust which is associated with the of gas is removed, and the dust content of the gas will be reduced to 4 to 6 grams normal meter to approximately from 4 to 6 grams to around 5 mg per normal meter cube, with about 3.5 to 4 liter of water consumption per cubic meter of gas. And then we have the next one is the electrostatic precipitator. That is the other gas cleaning unit. There, in the name itself, it is there. It is the electrostatic precipitator. So we pass some um, electrostatic charge, and because of this, the dust will be accumulated to the electrodes of opposite polarity, and that are collected and washed out. And here in the electrostatic precipitator, uh, principle is that under the action of high applied static voltage, the dust particles in the gas phase requires electrostatic charge and are attracted to the electrode of opposite polarity. And here at the top, there will be hammer will be there, and every time this hammer will hit to this plates, so that whatever the dust which is accumulated to the plates, that will be detached and settle down at the bottom. Here also there is two methods are there. One is the wet method, other one is the so the direct current, whatever is used in the precipitators, is of the order of 130 to 160 MA and 30 to 45 kilowatt. So the electrostatic precipitator consisting of either it can be tubes or it can be plates as an electrode, and the wire parallel with the plates as another electrode. So you can see it here. So you can see these are the plates and these are the wires which are acting as a electrodes, opposite electrodes. So the gas enters from the bottom and it will rise upward, while a thin film of water flows over the surface of the tubes or plates from inside towards downward direction. And the dust particles on ionization will certainly get attracted to these wet surfaces and are washed down. Again, the dust whatever is accumulated that will be in the form of slurry, and that will be sent to the tanks. So the dust particles are precipitated on the electrode. That's why it's called electrostatic precipitator. And the slurry, whatever it is collected, that mainly consisting of mostly of iron ore and is led to the thickener. Cleaning efficiency is, however, better in case of electrostatic precipitator, and hence it is practically universally it is adopted. And the clean gas, whatever it is produced by undergoing this three-stage cleaning system, that will be stored in a huge gas holder and is distributed from that particular area to uh, the rest of the integrated steel plant. So these clean gas, whatever it is there, this clean gas is basically utilized at a different areas. Uh, one such uh, one such unit is the BF house, the blast furnace house. There, the cleaned BF gas may be used for preheating the blast for the blast furnace to the stoves. So here you can see this is the blast furnace stove, and the cleaned BF gas is sent into this stove. The stove is basically vertically uh, refractory lined system, which is having a dome kind of structure at the top, and it is inside you have a refractory lining will be there, and this is divided into two chambers. One is the combustion chamber, other one is the refractory reactors. So the combustion chamber, the BF gas will be ignited at the bottom, burnt, and the burnt BF gas will be traveled up, and this will be called as a combustion zone because there's a combustion of cleaned BF gas will take place, and that will be travel and enters into this Tetra bricks. So these Tetra bricks, whatever are there, these are also refractory bricks, heavy duty fire bricks, which is present inside this stove. And whenever this heated of gas is traveling to the checker bricks will absorb the heat, and and then the gases will leave out from the stove. It is purely a heat transfer phenomena where the cold checker bricks will absorb this heat, which which is traveling through this by the off gas. And then from the outside, we take the ambient atmosphere. There is a suction of the ambient air will be taking place, and that cold air will pass through this preheated checker bricks. And again here there is a heat transfer will take place from the checker bricks to the cold air. So here the checker bricks, whatever we are using, it should have a property that whenever the combusted of gas is passed through the checker bricks, it should absorb the maximum amount of heat associated with the off gas. At the same time, when cold air is passing through the checker bricks, it should release the maximum amount of heat associated with it, the cold cold air. And when the stove when the when the when the um, when the stove is in on gas condition, that means the electrics are getting heated up by the BF off gas. That is called as the stove is in on gas condition. And when the when the ambient atmosphere, when the air from the ambient atmosphere, if it is passed through this preheat the checker bricks, and that is called as on blast condition. Stove is on blast condition. So So this is basically the on blast or on gas. See, the on gas takes 2 to 4 hours, and the on blast takes 1 to 2 hours for preheating of air, cold air. Okay. So the ports through which the hot blast air exit from the stove is located on the side of the combustion chamber, usually around 4 to 7 meter above the burner. You can see that exit here. This is the exit part of the stove. Okay. So whatever the preheated air, whatever it is there, that preheated air will travel to this combustion chamber and comes out from this combustion chamber to this particular outlet. And this preheated air will basically um, travel through the pipes uh, and it will be uh, injected into the blast furnace through the puzzle pipe and through the gears. So the checker work, whatever we have in the stoves, the checker work has to absorb maximum heat at faster rate while heating and should also dissolve the heat equally rapidly to the incoming cold blast. So this property, whatever it is there, so that means when it is when it is in the on gas condition, the bit should absorb maximum amount of heat from the air from the off gas, and when it is in on blast condition, it should release maximum amount of heat to the uh, ambient air, cold air. So that will be possible only when when the larger the weight of the bricks, uh, then that is possible because the heat storing capacity will be more. Okay. Similarly, the larger is the surface area exposed, as that the faster is heat exchange with the gas. So this two things. One is the brick should be larger in weight, and another is a larger surface area. So these both will help in absorb and dissolve of the heat. And the checker bricks in this stove is basically made of silica refractory. Okay. They are silica bricks. Actually. And the life of these checker bricks will be around 15 to 20 years. Yeah. So these are the stoves, whatever we have discussed here now, this particular unit, whatever we have discussed, that is nothing but this one. That is this one. Okay. So here you can see three stoves are there. One will be in the on gas condition, one will be in the on blast condition, one will be in the standby condition. Okay. So if any of these two are not working, then we can use the third one as the um, option. So it will always in the standby condition. And the uh, preheated cold air, whatever it is, comes out from this house, that will be sent to this mm, pipe that is connected to this pipe, and this pipe is connected to the Basal pipe. This is the Basal pipe which is located around the periphery of your blast furnace, and to this Basal pipe, the gear stocks are fixed. Okay, so whatever the air which is passed into this Basal pipe, that will be distributed to this gear stocks, and that will be and to this uniform distribution that will enter into the blast furnace through the gears. So this is the in this clockwise direction, you can connect it. The heated air comes out from the stoves, will enter into this main pipe, and this main pipe is connected to this basal pipe, and to this basal pipe, these clear stocks are connected. You can see the same thing here also. This at the back side there is a hash part pipe is going on. That is nothing but this one, and it is connected to the clear stock. So you can see here there is the puzzle pipe, and there is a clear stock is there here. That the puzzle pipe is this one, and clear stock is this one, and to that clear stock is there. So in this way, the preheated air hot blast. The hot blast is basically sent into the blast furnace with certain velocity. So with this, we will end this session of gas cleaning process, blast furnace gas cleaning system. The next class we will discuss about some of the irregularities of blast furnace and its remedies.